Hey guys, I just wanted to go over a problem from tonight's homework on part 5 of this worksheet. Um, Sorry, they're doing some work at my place, so there's some hammering, but let's look at number 12, that first one, today's worksheet. Looks like the same problem as last night's homework, except now they're asking us to write a step function instead of a continuous function. A step function is another way for saying a discrete function. This graph will jump steps. If you look at it here, you can see when we graph it what it's going to look like. But let's go through the steps. We're going to let x equal gigabytes of data, and that's on our horizontal axis. Let me try this tool. So that's there, obviously. And then y is the amount of Billy spends. That's up here. Again, we usually put money on the vertical axis, the y-axis. Usually we put time if there is time and a problem on the x-axis, but in this case there's not. But the money that Billy spends we put on the y-axis. That's just good. It's just best practices. To graph this step function, it's actually just a bunch of little straight line horizontal functions. And this would theoretically go on forever. Like, even though we ended it at y equals 105 for this step, we could keep going forever. Y equals 115 for number 6 is less than or equal to x, or is less than or equal to 7. So we could keep going with it. So like if I wanted to do the next one, and it's not going to graph, but at least I can write it, we could write y equals 115 when x is between 6 and 7, and actually including 7. So that's the significance of this, why this is greater than or equal to, and this is, or I'm sorry, less than or equal to, and this is just less than. Because if it's exactly 6, it's still going to be this thing. But if it's above 6 at all, even 6.0001, now it's going to cost him $115 for his stuff. And then if we were to graph that, we can see if we can zoom this up. We're going to graph y equals 115 when x is between 6 and 7. We would just look for 115 up here, so probably about, this is 100, this is 100, this is 110, 120, so 115 is going to be right about here, and in between 6 and 7 is right here on the x, so I would graph another one of these steps right here. And we do that forever and ever and ever for every extra gigabyte, so it looks like it's going to be jumping this much for each, and we would have a different equation for each of these. So you literally have infinite equations for this problem. The domain we said is x is greater than or equal to 0, since you can't have negative data amounts. And the range is y is greater than or equal to 65, because there's no way you could pay less than $65 for this cell phone plan, or Billy, yeah, whoever's buying it. Other things about this problem, it's discrete. Any step function is discrete. Any function that jumps like this is going to be discrete. Also, one more thing is, be aware that a lot of real-life graphs only have positive components. Like, they don't have you have nothing in this graph in any of these quadrants. So maybe think about a graph like this where you know the domain and range are going to be positive. Just use graph paper with one quadrant, or just use something, just use this part. You don't need all this space, this paper wasting space, if you know the graph's not going to go there. So we're moving into some real world stuff, which is cool, and graphs that you could use in the real world. This is probably one of them, and it's only in the first quadrant of the graph, so consider maybe only using a one quadrant graph for this type of problem. Also, one more thing, on any of these, if you guys catch a mistake of mine and let me know about it, I will make sure to reward you for that. So if you see me doing something wrong and you're like, hey, this isn't right, make sure to ask me about it next time we talk, or send me an email or whatever. But that would be awesome to help me, and also it shows me that you're paying close attention and know what's going on. So I would super appreciate that. Guys, I hope this helps. Good luck on the homework tonight.